about refractive index, the plural is indices. There are two types of refractive indices, that is absolute refractive index and relative refractive index. What is absolute? Nirapekshya. Relative is Sapeksha. So you just think about a vacuum. A vacuum is a medium. Actually, there are no particles, no mass, no matter. So therefore, vacuum is a vacuum. When light passing from vacuum to a material, just think that light going from a vacuum to glass. So for that, we can talk about angle of incidence and angle of refraction, even when light going from a vacuum. So when we write the refractive index for that specific situation, where one medium is vacuum, we call that refractive index absolute refractive index. Why? The first medium is a vacuum. So therefore, when light going from vacuum to a particular medium, the relevant refractive index is called absolute refractive index. If light going from one medium to another, a medium other than vacuum, if the medium has no involvement of vacuum, that refractive index is called relative refractive index. So for example, when light going from air to glass, A nu G, relative refractive index. When light going from water to glass, W nu G, relative refractive index. So therefore, there are two types of refractive indices. You can see when light is going from one medium to another, the refractive index is called relative refractive index. For example, A nu G, a medium other than vacuum. And when light is going from a vacuum to another medium, the refractive index is called absolute refractive index. Well, you can see another thing that here for absolute refractive index we use only one suffix. We don't use a suffix for vacuum. For example, here I have written Ng, nothing Ng, nothing Ng, Ng, not Wng, not Amg, just a mere Ng. Why? For vacuum we don't use a suffix. The relationship between absolute refractive index and relative refractive index, you can see that W nu G is a relative refractive index. The relationship is the ratio between the two absolute refractive indices give the relative refractive index. For example, W nu G is like going from water to glass. That value can be taken, that refractive index can be taken when you divide the absolute refractive index of glass when divided by absolute refractive index of water. So that is the relationship, right? A numerical example. You can see absolute refractive indices of different things. Water 1.33 and paraffin 1.44, perspex, that is glass 1.49, that is 1.5 basically, perspex, glass, soft glass, that is 1.52, and diamond highest 2.42. And you can see the numerical example worked out. That is W nu G. How can we find W nu G? If we know the nu G and nu W, we can find W nu G. Yeah. So W nu G equals nu G divided by nu W. Nu G is 1.52 nu W is 1.33. When divided, you get the answer 1.14. The relative refractive index when light passing from water to glass. That's it. One thing I should mention here is that to solve good numerical problems of refraction, you should learn two other things. That is total internal reflection and critical angle. When you learn these things, you can solve good advanced questions of refraction. Until you cannot, basically. So therefore, in today's lesson, I'm not going to give you numerical examples, because in next video, most probably within 2 days, I'll do the video. In that, I'm going to work out a good number of questions, advanced questions of refraction, after teaching you total internal reflection and critical angle. That is for today's lesson. Bye.